asked for the length of the line PQ in this question. It's quite easy to get caught up in thinking, oh, I need to work out a load of lengths, but you actually don't. It's all about the angles in this question. And I'd always say, like, if you can find some angles, then find some angles. There's been plenty of math challenge questions where I've got carried away using more advanced methods and actually missing like an isosceles triangle here or there. So let's deal with some angles. We've got an octagon. So the first thing to do is let's work out the interior angles of a regular octagon. In fact, they're 135. That is worth knowing. Otherwise, you need to do the number of sides minus 2 times 180 divided by 8. Okay, cancel this down partially. 4 and 90. And then, okay, 3 and 2. 270 divided by 2 is going to be 135. I'm not sure I did that best way, but I got there. Okay, now what I then notice is, oh, and I should just add actually, so the sides are length 1, so this here is 1. And actually that there is 1. Okay, I'll focus on this left-hand side because it is, there's a line of symmetry going down the middle. Right, because I've got 135, I've now got an isosceles triangle here, ABC, which means that I'm splitting 45 degrees between these two angles, and they're both going to be 22.5. Now I can't say that this one's 22.5 because then they're not vertically opposite. It's not like an X because they're not, this sort of takes a turn at that point. But I can say that that there is going to be 135 minus 22.5, which is 112.5. And then I've got a straight line here, which means that that is going to be 67.5. So I'm just calculating these angles, why not? In fact, it's going to be really useful at this point here because I've got 135 here as well, which means this is 45. And then to sum this up to 180, well, you can either add them up and then do 180 minus that. But you might be able to spot that it's if I double this one back to 135, then all I need, is to make this 67.5 to make it all check out. Okay, this is great because now I've got another isosceles triangle. This here is actually the same as this, or they're all the same in fact. But essentially, PD is the same as the length of the octagon, meaning it's also 1. By symmetry, this one is also 1. Add them up, the length of the line PQ is necessarily 3. Fantastic question. Well done.